Yeah, I want to start streaming.
The official one.
Okay, finally. Finally. It's maybe because like I started to play around with the events on YouTube, so that's why. So now it's starting. Yes, finally.
Okay, finally. It's maybe because like I started to play around with the events on YouTube.
I wanna see that other computer as a monitor. Shouldn't go to sleep so soon. Or I will set up this one just to see whether it works or not. So yeah, we'll wait for 10 minutes more to kind of more people to arrive also. Okay. I wanna hear a sound back.
Click on live.
Sorry?
Click on live on the screen.
Here.
Yeah, so it's live.
Ah, okay.
Can you hear sound?
No, maybe this doesn't have speakers.
Yeah, maybe it doesn't.
Oh. TV volume, yeah, but I didn't set it to TV. That's one. Ah. Ah, no, it's talking. Yeah, it's the computer talking. It's not the TVs. I don't know. Like the TV doesn't have really good.
Do you want audio?
No, not really. So because then it will loop in the current screen. Let's see. Bookmarks, no. So showing desktop. It's not really live. Okay. Yeah, I think that we could start. So it's So this time it's welcome to Fab Academy Thursdays. So it's an activity which we started as a part of the Fab Academy, which is a half-a-year-long course about how to make almost anything. It's quite hard, and I joined it last year. And what I can say, what I saw is that there are a lot of beginners who are struggling with the topics. So every week there's a new topic, and so basically they are struggling so much because they do not have any basics around. So and then we made these Fab Academy Thursdays in order to kind of try to cover the very basics of all the topics involved. And today I will try to make it really short and simple, like introduction to Arduino. So we did play around with Arduino a little bit in one of the previous live streams where I tried to explain the basics of electronics, which is not an easy task, but I tried. And today I'm just going to cover more the programming side of the Arduino, but also not so very in-depth. So in a perfect case, you should have an Arduino yourself. If you don't, then we can actually find one at the Fablab, and then you could try to follow along. Are you interested? Good. So here's going to be one Arduino. We'll need also a breadboard for you, something like this, and then we will need also a USB cable. USB cable. I hope that your computer has one of the older USB ports, like the USB-A. Yeah, it looks like it has. Yeah. Arduino started some time ago, so around 10 years ago, in Italy. So Massimo Banzi, together with other engineers at the time, they were teaching at the school. Was it like ITP or at an art school? And so they had this idea that that electronics could be used for artistic projects, but so they faced the same problem, how to teach electronics to people who not necessarily have any background in it, and it usually involves so many layers, and and a lot of theory. So it used to be like that. And they tried to find a way how they could reduce the workload, so how they could reduce the time needed in order to get into the electronics. So Massimo and his team, they developed a board which is built around a microcontroller, which would be relatively difficult to program otherwise, but they built an interface, like a layer around it and over it, in order to make it easier to program. So if you take a look at the website here, and we go to resources and products and Arduino products, nowadays there are like all these different kinds of Arduinos, but initially there was only one. So an Arduino Uno is the most direct representation of how it used to be in the beginning. And as you can see, it has like this black brick in the middle of it, which is the 80 mega 320 microcontroller. So yeah, 328p. Yeah, which has 32 kilobytes of memory and other properties. So this clock speed is defined by an external clock that you can see here. So this little thing here. Where's my mouse? Yeah, now. Yeah, this is the clock over here. Then they added also a USB port, which allows your computer to communicate with it. Then there's an ISP port, which is used to burn the bootloader, and once the bootloader is burnt, so Arduinos usually come with a bootloader already on the chip, so which makes it possible to program it by using the USB interface. And then it has like these pins, these sockets, little sockets over here, which are basically mapping directly to the pins on the IT Mega microcontroller chip over here. This is not the ISP, I think this is the ISP programmer here. Yeah, this little chip is responsible for USB, and this one is probably a power regulator, but yeah, that doesn't matter so much. So it's actually also originally inspired by another platform that's called wiring. So before Arduino, there was a wiring platform, which was initially developed by a student of Massimo Banzi, as far as I remember and as far as I know. Yeah, and the idea behind Arduino is also that, and also behind wiring, is that these will be open source boards. So the design files will be openly available, and anyone with enough electronics knowledge, they could copy the files and they could make their own Arduino boards if they would want to. And also the software. So on the software side, so usually in order to program these chips, you need it's used to be so that you need like commercial, quite expensive software that is able to interface with specific AVR programmers, and it would be closed source and all that. But in this case, so the team decided to release it also open source, and they released to base the interface on another open source project at the same time, which is called Processing. Which is another interesting arts and coding initiative, which is so like a project that is supposed to make programming easier for beginners. And if Arduino is a platform that is supposed to make electronics easier for beginners, then Processing is a platform that with a goal to make it easier for beginners to start coding. Yeah, if you open Processing, do you have it installed somewhere? No, I don't have it installed, but yeah, the thing is that if you will open Arduino and if you know Processing, then you will see that the interface is very similar. So we can check out some images on Google. So here you can see something that looks similar. So there's the window that you see. What is happening? Why can't I just open the picture from here? Yeah, this one is more like it. So you see there's it's a really simplified interface. Basically, it's a text editor which colorizes text depending on the programming language that you're using. In the case of Processing, the programming language that you're using is Java, not JavaScript, but Java. And in the case of Arduino, it's C language. But yeah, it's basically a text editor with some additional features, like these two buttons. They are the most important ones. So it's play and stop, basically, and on the bottom you have something like a field where the computer says what it thinks about your code. Yeah, and if we go back to the Arduino IDE here, then so we can see that it's yeah, this has similar layout. So there are some buttons on the top. then there's a text editor, basically with colorized text, and then on the bottom there is a black screen, which is the place where your computer is going to tell you whether you are right or wrong, and or whether your code is right. If it's not right, then it will try to hint you where the mistakes are. And yeah, since in AVR programming, C language is very popular and kind of the de facto language that is used to produce code for those. Then so basically Arduino is kind of a library or a layer, like a library, a set of functions that are written in C language on top of the C language framework, and so it's full of functions and conventions that are supposed to make your life easier as an AVR programmer, as a chip programmer who wants to make interesting things with electronics and maybe connect this electronics with computers, and control electronics with computers, and control your computer with electronics. And so now if we look at the camera again, so here, can I, yeah, I'll scale this up a little bit. So yeah, so here we have an Arduino on our table. Oh, maybe I should flip it around. So I'll disconnect from the computer. Yeah, here you can see the most important things that you need to know is these are the digital pins here. They are 14 and they are labeled from 0 to 13 or here. So here it ends. So to 13, 0. So in programming, usually things you will start to count things from 0. So basically, you should shift the 0 like by one value forward, and you will arrive to 14 instead of 13. And then after these, so these digital pins, what it means? So digital pins means that they can have two states. One is off and one is on. So basically, when it's off, then it's 0 volts, and when it's on, then it's 5 volts. Some of these pins, which are labeled with a tilde character, so these are the so-called PWM pins, or if you translate that acronym to actual terms, then it means pulse width modulation, which means that you can turn these pins on and off at very high rates. So you can turn other pins on and off at very high rates, but the difference is that these PWM pins, they are, so the functionality is predefined or is supported in this chip. So basically in this chip, when you write a program for it, you can specify a value that is going to be translated into these pulses here into the pins. So these other pins that are not the PWM pins, that so you can switch them on and off also at high rates, but then the translation of the value to the actual frequency you have to do yourself on the software level. But worry not, so it's just one additional step. So basically in this chip there's also nice timing capabilities, so you can when you start it up, then you can actually measure time, so it can measure time with a microsecond or 1/1,000,000th of a second precision. So in taking that into account, so you can do PWM yourself even without the PWM functionality on the chip. That just in case if you want to have all of these pins as PWM. So where PWM is useful, it is when you are fading things. So we are gonna cover this later. fading things like LEDs, so you want to make an LED brighter or not so bright, or you want to a motor to spin faster or slower, things like these. Then on the other side, so these pins here, these are the analog pins, so you can use them also as output pins, as output digital pins, but these are special with the fact that you can measure voltage, so you can use these as sensor input. And there are the so-called simple sensors like light sensors, temperature sensors, force sensors, and so on, that you can connect here. And when you use these sensors, they are going to change voltage, so they are going to change the flow of current, so they are going to become more resistant or not so less resistant in terms of so they are going to block some part of current flowing through them, and which also is going to result in the change of voltage. And these pins are connected to subsystems on this chip, which are going to translate this voltage into numbers. And these numbers you'll be able to use in the program inside of the chip in order to do some things depending on the numbers. So you'd say if the number is higher than 500, then you do this. If it's less than 500, do that, or you can also map it to certain values and so on. And here, so this part, so it's more like sort of a utility pins. So here it starts from voltage in, and you can use this pin to, so for example, after you burn the code, after you program the chip, and you don't want the Raspberry, not the Raspberry Pi, but the Arduino to be connected to the USB cable anymore, but you would like to use your own battery or other power source, then you can use this voltage in pin as a place where you supply voltage, where you attach the little cable which is going to be the plus terminal of your battery. And then just next to it you will see that there are two ground pins, so you would connect the ground pin of the battery to one of the ground pins, and then there's a 5-volt output pin, 3.3 volt output pin. So these two you can use to drive things that are running on 5 volts or 3.3 volts. So these can be, you can use Arduino as a power source as well. So for example, you could connect it to USB, and then just to try out things, you could use these two pins in order to connect them to the breadboard and try out some lights or motors or whatever electronics you have, relays and so on. Yeah, that's about it. And what is like reset? I never had the reason to use the reset, but I think there's a button as well. So I think it's when your program goes wild and it starts to do weird things, and you need to reset, and you can press this and watch the program running from the very beginning. And IO reference. An A reference, yeah, we need to look up this, but yeah, so this is supposed to be very simple. So today we are going to focus only on the digital pins actually, and in order to do that, we are going to first use the built-in LED here on the board. So this little thing chip here, it's actually connected to pin 13. And from Arduino code we are going to be able to drive it. So let's do that. Let's switch over to our desktop. And yeah, so you can download Arduino software, by the way, on Arduino CC. When you go to software, downloads, you can also use the web editor. You can also download one of the versions that you see here. yeah, I use the Mac version and so on. Yeah, once you downloaded it, then put it in a safe place and try to open it up. And when you open it up the first time, you should see this text over here. So it starts out with 2 function definitions, and let's go over what it actually means. So in C and also C++, usually, so everything that you will work with, either it's a variable or a function, should return some sort of type. So it's so variables are separated in types, and also every function that you write that does something, it should return something that is a certain kind of type. Even though the function, even your intention is not to return anything to others, to other functions or into the main program, you should specify the type, in this case void, which means nothing. So the type is nothing. Even though it's nothing, you should specify that it's nothing. Then the next thing here is the function name. Then these brackets are opening and closing brackets. In between them, you would have sometimes some input variables that you would like to pass into the function. And these curly brackets, they specify the body of your function. So in between those, you would define what the function should do. So these 2 functions are essential to Arduino in a way that the setup function is going to be run once when you connect Arduino to power. So it's going to boot up, and the first thing it's going to do is to run, of course, after running the bootloader and things like that, it's going to run the setup function. So this is the place where you normally would set up pins, whether you would specify whether they are input pins or output pins. And then the other function is loop, which would run as long as the Arduino is connected to electricity. So it will loop over and over again and as fast as possible. So in order to specify how are we going to use the pins, we need to use the function that is predefined in the Arduino library, which is called pin mode. And this function accepts parameters, and this is why we are using these brackets here. It expects us to give it a number, which is the pin number. So you can see the pin numbers on the on the board. So if you look here, then these are the pin numbers. So these also map to the actual numbers that we should specify for the pin mode function. And I'm gonna go back to here and here. So yeah, for the pin mode, the first parameter that we need to give is 13. It's gonna be the pin that is also connected to the onboard LED. And we need to specify what are we going to use it for. Is it going to be input or output? And in our case now, it's going to be output. And this is it for the setup function. Yeah, we can save it also, but not now. And then we are going to use the digital write function in order to do something with the pin. And there are 2 things with the digital pins, as we discussed before. One thing is to turn it on, and the other thing is to turn it off. So, and again, we need to specify the pin number and high. So yeah, these are translations. You can use high or low, or you can also use 1 or 0. So I think 1 is also clear, but let's go with high. Then there's another function which uses the timing integrated on the chip. So it's just called delay. And for the delay function, we need to specify time in milliseconds in order to generate a delay. So the chip is going to wait for some time and do nothing. And let's wait for 1 second, which is 1000 milliseconds, and then use the digital write command in order to turn the pin 13 off or low. And then just after that, let's use another delay, also 1000 milliseconds, in order to keep it low, keep it off for some time. And then after this, so the chip is going to recognize the end of the block, and it's going to jump over to the beginning and repeat the same thing over and over again. Yeah, so let's switch to the camera. And so we need to use a USB cable now in order to connect the Arduino to the computer. So on your computer, so the other end of the cable should be compatible with your computer's USB ports. So you connect it there. And I'm going to go back to the desktop again. Control D. And here, like on the interface again, you need to click on Tools, and you need to select to specify the board that you're using. So as you saw on the website, there are many types of boards. So these all map to one of them, the one that you have. So in our case, we have Arduino Uno. We need to select that. And then another thing that we need to specify, the port that we are going to use for programming it. And in this case, so yeah, on Mac it's usually dev / cu something, and it's yeah, Arduino also gives me hint that it's probably that there's Arduino connected. Like on Windows, it could be COM3, COM2, depends. But on Linux, you would see something similar to this dev / cu. I think on Linux it would be TTY. Yeah, once that's selected, you can actually, yeah. So there are two things that you can do. So one is verify. So before you do that, you should actually save it. I'll save it as. Here. And so this verify, what it actually does, it basically compiles the code and checks whether there are errors. So it tries to compile, and if it doesn't compile, then it notifies you about possible errors and where to find them. And then the other button here on top is the upload button. And this is used to upload code to Arduino. So I'm going to press it now. And here on the bottom part, you will see that it's yeah, that it's done. And thank you. And so that we uploaded it now. And now what we need to see is what's going on with the actual Arduino. Oh no. I think yeah, so this one. Yeah, so and if we look closer, we see that there's one LED that blinks with a 1 second interval. And I'm going to launch the upload script again, and you will see that next to the LED that blinks over here, there are two other LEDs which are labeled TX and RX, and these are going to blink when the Arduino is being programmed. So now I click the programming button. You see, yeah, the code is really not much, and yeah, it happened really quickly. So one more time. You see, it was just a few blinks and that's it. So yeah, and so in order to have a greater effect and in order to see how it's can drive something external to Arduino, we are going to use the breadboard. And with breadboard, so it's nice for learning, but then in order to build real circuits, it's maybe not the best thing to use. But for learning and just trying out things, it's perfect. So just to test whether a component works, or whether you are using the right approach or you understood things correctly. And it is a board with connections, and so each of these little pins or sockets over here, they are connected to some place in some way. So these here are connected in this direction, so to the left to the right, from the left to the right, and that means that all these how many, like five pins are actually connected with one wire. The same goes for the one parallel to it. So it's disconnected from anything else. It's just connected with the other pins on this line over here. The same with this and all the other pins here parallel. It's a bit different with the pins that you see on the sides. So they are labeled plus and minus. So the plus ones, so you see that there's like also a long red line. So these are usually connected in the top-down direction like this. So if you plug something in here, you can be sure that it's going to connect to something over here, like, or in any of the other pins along the way. So the same goes with the minus rail. And these two on the bottoms, on the both sides, these are disconnected. So this line also defines, declares that there's no connection in between these two sides, which makes it really handy if you want to connect chips. So chips usually have separate connections on each of the sides. So like this Arduino chip here, for example. So these pins to the left are completely disconnected from the pins to the right, and we could actually use this in order to plug it in into the breadboard, just like that in the middle. So the left pins are going to connect to the parallel connections over here on this side, and the other side, the pins on the right side, they are going to connect on to the pins, to the separate lines on the right side. Yeah, so let's use these two rails. Let's use one of them. So first let's connect the negative rail to ground. And let's plug in this LED. So this is a red, rather big LED. And what you should know about these kind of LEDs is that they usually have this longer and shorter leg. So the longer LED should always be connected to the plus or the positive voltage, and the negative one should be connected to minus. So with that in mind, I'll put the plus to the left and minus to the right, and then in between those I'll also add a resistor. So this is a resistor, and the good thing about resistors is that they do not have polarity, so you can use them in this way or the other way around. So it doesn't matter if you connect plus to the left terminal or to the right. And we are just going to connect this to the minus part of the LED and to another pin over here. And then the plus side, so we are going to use another jumper wire here. On the plus side of the LED, we are going to connect to pin 13 on the Arduino. And then the other end of the resistor, so you see the connection now goes like from the plus of the LED here through the LED to the minus. Then the minus connects to the end, to this resistor, to the one end, one leg of the resistor. So you can imagine that the current flows through the resistor and it goes here. And then from the other end, other pin of the resistor, we are going to connect that to the rail where we have the minus connection. And now it blinks. Yeah, we have jumper wires over here. So.
You have some LEDs?
Yes, also LEDs. Like this is the amount of LEDs we have.
Do you have a spare Arduino?
Yeah. So. Okay, now let's make a 1-minute break. I will get something to drink. Yeah, the breadboards are on the bottom shelf, in the bottom drawer.
The one I didn't put. This one, I don't know if they borrow the other one.
Okay. Yeah, I will try. I will find out.
You can share this one if you want.
Yeah, that might be good.
Great, thank you.
Oh, hello.
Okay, so ground.
For what? VR? Scarf? It could be here. So if it's here, then it should be here.
Well, this was during the opening. And I think it was, oh, it's still there.
Ah, it's there. Okay. Yeah.
It was camouflage.
I remember you were asking about me. About that me.
Because it's like well hidden by the green.
Yeah. But I think it's more like I forgot to look for it.
Okay, man. I'm going up for one VR cinema lab thing.
Yeah, I heard they are like starting it now, so it's gonna be on Thursdays as well.
You're doing the open day today, right?
Yeah. So now we are doing like a little intro into Arduino.
Okay. Not many people. Only 40.
There are like other online.
And now
You can update your data here. Yeah, it's perfect. Yeah. Sometimes this setup for me.
Too late. So okay, now let's say we want to change the pin to another number. And if we want to do that, then we need to change all these 13s to another number. So these are three separate operations. And let's say that we have the code is a bit more complex and we need to change it in 20 locations. In order to avoid that, we can use a thing that is called a variable that will keep the pin number in it. And one of the basic types of variables is integer, which is specified by, like int stands for integer, so it's a data type. So as I told before, like functions, and so we usually in programming we work with variables or functions, and both of them, they are described by the data type they are returning. So an int is an integer, and usually these are 16-bit, sometimes 32-bit data containers, which can hold decimal values. So something like 1, 2, 3, or 5, or -1, -2. If it's a signed integer, it can be also an unsigned integer, which means that it will be able to hold only positive numbers. And in our case, it's basically what we need. So it's unsigned integer, and we need to give it a name. So it's going to be our pin, LED pin. So that's the conventional name for these kind of introductions. And we are going to assign number 13 to it, and then we are going to replace all these 13s to the variable name, and then the program is going to replace this name, this variable name, LED pin, to the number that we specify at the top of the program. Yeah, and let's say that we now want to change the LED pin to 12. Easy. We just change it here, and it changes everywhere else as well. So let's try to do that on the camera. So here, yeah, like instead of this cable being connected to pin 13, let's connect it to 12. So as you see, it stopped blinking because the program is not yet there. So I'm just gonna hit this upload button, and it's going to upload, compile and upload it to the board. And now when I go back to the Arduino, you see it blinks again. In the same way, so let's try to use the same code in order to add another LED. So let's go back to the desktop. Oh no, I failed. So here, and let's add another LED as a variable, assigned LED pin 2, and let's rename this to 1. 13. Let's specify the LED pin to output, and then use pin mode LED pin to output as well. And 1. Yeah, I just changed the existing LED pin variable to 1 everywhere, and so I copy this line that turns the LEDs on, and turn the LED 2 on as well, and then I will copy this LED pin 1 low, line and map it to LED 2. So now we should have two LEDs blinking. I'll upload the code. We are not going to see that yet. I know we are going to see that. Camera. So we see that there are two LEDs blinking. One is on the board. Actually, it was like that before, but now we are using two separate pins for those. But let's make the connections. So I will add another LED in a similar fashion as I added the previous one. So I'm gonna keep the positive longer leg to the left, and then the shorter leg to the right. And I'm going to connect it here, and I'm going to take a resistor. So these resistors are around 100 ohms. Just in case you're curious. So there's a way how you can tell what kind of resistor you need. Just recently I found a really nice resource on the website. It's called The Evil Mad Scientist, and it has a nice article about how to pick resistors for LEDs, and it involves checking some values on your LEDs, and also knowing what your power supply is and looking up the data sheet of your LEDs. But yeah, there are also some things that are normally there. So the fact that the LEDs usually pull around 30 milliamps of current, and then there are some calculations. So let's switch back to the camera and let's finish the connections. So I'll take another jumper wire, like a red one. And connect it to pin 13. Yeah, which is in between the ground and pin 12. And it needs to go to the plus. Yes, the plus pin, and then I will connect a blue jumper cable from the resistor to the ground on the breadboard. And now they are blinking, both of them at the same time. It's not necessarily what we want. So what we could do in the code is we actually look at the loop function, and we could avoid switching both of the LEDs on at the same time. We could actually switch one off and the other on. And then when we turn both of them off, we could switch the first one off and the second one on. And let's upload the code, and let's take a look at how it looks now. So you see that one is on, one is off. It's a bit blurry though. Yeah, it's better. So this is how the circuit looks like. Oh, you're trying the small one.
We're out of Arduino, at least working one.
Ah, okay, yeah, like the three Arduinos the wearable electronics
Yeah.
you guys have.
Yeah.
But maybe we should purchase some more,
Yeah.
or we could actually maybe
There's
just
the
order
wireless one.
ourselves if it's maybe cheaper. But maybe it's not cheaper because we also will need to put some work in it.
What?
Soldering.
Yeah.
Yeah.
Yeah. Maybe some with the wireless would be cool though.
Yeah, the wireless ones I think it's yeah, it's like pretty much what people are looking for.
It's better than my first computer.
Wow. Yeah?
Yeah, those are really cheap from China.
Oh, great.
China.
Yeah. You can use Arduino to program it, right?
I think you can just plug that in.
Yeah.
Yeah, it's $2.
Yeah. Pretty
Wow.
ridiculous. That's why the toasters are getting Bluetooth and wireless.
Mm.
It's so cheap.
Yeah.
Why not?
I bought one of these. I hadn't done anything with it.
Yeah, it's also where will you use it? But yeah.
It's a microcontroller.
Oh, you broke it.
Yeah, I broke it.
Why?
I'm making another.
Strength test.
Okay, so there's this other concept that's called the PWM. So I explained it before, but let's try to make use of it. So just a second, I'll bring this on. So yeah, I'm gonna save this and I'm gonna start a new sketch. So I'm gonna keep them side by side for now. And for this one, we are going to define a variable which is going to specify the PWM pin, also unsigned integer PWM pin. And if you look at the board, then we see that there are these little tilde characters all over the place, and we need to choose one of those pins that are labeled as such to be able to control the brightness of those. So the first one is number 3. So let's pick number 3 as our PWM pin, and we need to set it up as output as well in a similar fashion as we did with the other pins in the previous example. Then mode PWM pin and output. So if you are not sure what to write and what commands are there available, you should go to Arduino reference or tutorials on the Arduino website. So here's a reference. And here you can see that like all the things that you can use that are predefined by the Arduino superset of C, so to say. So all these functions are making your life easier but less flexible in terms of microcontroller programming. But if you're just starting out, then this is great. So you can do some maths, you can do some things with characters, yeah, with pulses, with time, USB, and so on. So let's get back to Arduino. So yeah, so we set the pin to output, and here in the loop we can use the analog write to write values from 0 to 255. To 255 So this is the maximum value that actually 8 bits or like eight numbers, like 8 bits can hold. So if you consider that each of the bits can be 1 or 0, and then there are 8 positions, so there's this formula that if you power 2, which is the amount of digits that you use, by the positions that you have, respectively 8 bytes, you are going to get the amount of combinations that you can have, which in this case is 256. So what the chip does on Arduino board, it translates these this 1 byte that we are giving to it into a number or into a certain frequency that then is being converted into pulses. And I think that this is just a certain register which we program to accept this value, and then the chip is reading that register in order to determine the frequency. So so it's this. So the minimum is 0 and the maximum is 255. And you can also specify anything in between. So what we are going to do, we are going to create another variable which is going to specify the brightness. Which is going to start from 0. And here I'm going to save this as an example as well. So we are going to start with 0, and then after we are going to use this value for analog write. And then we are going to have a delay of, let's say, 15 milliseconds. And then we are going to increase the brightness by 1. Like this. And then at some point we are going to exceed the number 255, so the value. So, and we want to somehow limit that, and from 255 we want to return to 0 again. And for this we can use an if statement, which is a really great feature of any programming language, which lets us compare values to one another. So it starts out with if, then we need to specify the condition in between these brackets, and in this case it's going to be if brightness is bigger than 255. And then what happens if the condition is met? So if the brightness is bigger than 255, then it executes, then it runs the code that is inside this, in between these curly brackets. And here we set the brightness to 0 back again. And then it's going to exit the if statement, and then it's going to see that it's the end of the loop, and it's going to go to the beginning of the loop and repeat all this again. And now if we hit, I'm not going to hit upload yet. I'm going to switch to camera. And I'm going to rip this off. So let's remove all the cables. So what do we need? We need to connect the pin number 3. To an LED on the breadboard. So I'm gonna put here again. I'm gonna put the longer leg on the left side and the shorter leg on the right side. And then I'm going to connect the pin 3, so the wire connected to pin 3 to the longer LED by using these connected pins over here. Then I'm going to use a resistor again. Put it slightly diagonally so it spans only one pin like this. And then I'm going to use a blue cable in order to connect to the ground pin on the Arduino, and then another blue cable to connect the other end of the resistor to the rail of the negative, to the ground rail on the breadboard like this. And now I'm going to switch back to the code part. So the code is here, it's nicely saved, and I'm gonna hit upload. Yeah, the code is there. And now we switch back to camera and we take a look what is going on. You'll see that the LED fades to the maximum brightness and then it returns to 0 and it fades back in again. Okay, here. And lastly, yeah, well, so let's try to get to this point. So I'm gonna switch back to the code part so you can see the code. And then the next thing that I want to do, I will let's try to make use of all of the PWM pins, and also another programming concept that's called the arrays and for loop, in order to make them kind of make a really nice, LED strip kind of animation with fading LEDs. So how far did you get?
Yeah.
Oh, great. Okay. so we can continue. So I will close the previous one and I will make a new example. We are going to start out with this code that we already have. Yeah, let's switch to camera and let's check what are the other PW pins that they have here. So if we take a look, then the tilde is next to 5 and 6, and then 9, 10, and 11. So altogether we have 6 PWM pins on, there. So 9, 10, 11, and 5 and 6. So how about we put them in a container for easy reference, so that we don't need. So when we are going to make 6 different analog write statements, then so the code can become quite long and hard to edit. So instead we are going to use unsigned integer array, which we are going to call PWM Pins. And for an array we need to use these square brackets. So this is going to tell the compiler that, hey, we are actually talking about an array here. So it's like a certain number of values. So if you know the length of the array, then you can enter the number, or there's another way you can use these curly brackets in order to specify separate numbers. So it was 3, 5, 6, and then it was 9, 10, and 11. No, 11 like this. So, and basically what we did, we just defined a container with values which will be numbered from 0 to 5. So 0 is going to be the first value, 1 is going to be the second one, 2 is the third, 3 is the fourth, 4, 5, and 5 is going to be the sixth, or the last element. And we'll be able to access those by using the variable name and square brackets, and entering the number of the pin that we want to access. So we can transform that one into a syntax like this. I'm gonna save it somewhere. Yeah, and we can delete the PWM pin. It's interesting that it doesn't work like that. And we can actually do the same with brightness, and we can specify the brightness for each of the values, for each of the pins separately. And we can start with the gradual, so we can actually define them as gradually increasing. Like this. So there are 6 of them, and if you want to see the way how they map together, we can also use something like a nicer spacing, like that. So now we have a list of pins that we are going to use for PWE output, and then also values that are mapped to them. And instead of setting the mode separately for each of them, we can use a thing that's called the for loop, and it looks like this. So it starts out with 4, which specifies that it's a for loop, so the compiler will know that it has to use a certain kind of strategy to decode it. and translate it to microcontroller language. And then we have so these brackets, so where we are going to define so how the for loop should work. And then of course the curly brackets, in between those you will specify what should happen every loop. And so what do you define, what you specify in here in between the normal round brackets is it actually consists usually of 3 parts. One is you start out usually with a variable, which is of the iterator. So usually people use the letter I, or it could be also like the index, like pin index. And so we set its value to 0. And then so we need to add this semicolon, so it's just the syntax, so there's no other logical explanation. It's just like that, so it kind of declares that this is the end of the statement, of the first statement. And then we need to specify the condition, so when the loop is going to run. So if pin index is less than 6, and then what should happen after each loop? So after each loop, the pin index should be increased by 1. Like this. So I will close this one and make this wider, like this. So we start out with pin index that is 0, and then until pin index is less than 6, then we are actually running the loop, and after each of the loop we are increasing pin index by 1. So pin index equals pin index plus 1. So what is going to happen? So you're going to enter the loop. So the program or the microcontroller is going to enter the loop. It's going to do whatever is in here in between these curly brackets. Then it's going to detect an end of it, and it's going to go to this last part. So it's going to increase the pin index by 1, and it's going to ask whether the pin index is still less than 6. And for the first 6 times it's going to be, but at some point it's going to reach the value 6, and it's certainly not going to be less than 6, and then it's going to exit and continue. And it's going to happen really fast. And we can use this in order to set the pin mode. So, and instead of using this 0 index in here, we can just replace this 0 with pin index. And this is a way how we will be able to use these non-linear numbers in order to set all these reference pins as output in one go. So, and instead of using 6 lines to do that, we are just using 3. And then in the loop, so we can repeat this. So we can take this for loop, we can copy it here, and we can analog write the pins, so analog write pin that is specified by pin index at the point, and the brightness, since we have the brightness as an array now as well, so we can use the square brackets in order to specify which of the brightnesses we want to use for the specific pin. And then we add a delay after setting them all up, and inside the same for loop we can also set the brightness of each of the brightness values, and so the brightness with a square brackets like this, pin index So we are going to add 1 to each of the brightnesses of the LEDs at the same time. No, not 255. Plus 1. And then we are going to use this if statement and check if it's more than 200, if some of the pin brightnesses are more than 255, and if they are, we are going to set the same back to 0. And then after the whole for loop, we are going to use 50 millisecond delay. Yeah, now the fun part is going to be to actually make the circuit in a way it can react to the code that we just wrote. I actually am still... So yeah, once more. So here at the top of the code, we are defining a new container or array called PWM Pins, which is going to hold unsigned integer numbers, which are going to be the indexes of the pins that we are using on the board. So these square brackets are telling the compiler that it's going to be an array. And then with this curly brackets, we can specify we can specify on the fly what are the values going to be, and then so we do the same with the brightness. So we are specifying the brightness to be as an array container, and then we're using the curly brackets in order to specify the values. And as you see, we are gradually increasing the values for each LED. So so if you think through, then you kind of can imagine what could happen, but I'm not gonna tell you yet. So you'll see it. So then yeah, this is the setup function. In the setup function, we use a for loop, so which basically works in you have to define 3 things for it. So you need to define like a starting this is the first part is kind of a setup function. It's being run once, so you initialize the for loop. So you set a variable there, so the pin index. You define a variable pin index, which you set initially to 0. Then after each loop, you check whether this pin index is still less than 6, which is the amount of pins that we are using for fading or for PWM, and then also after each loop we are increasing this pin index by 1, and then it goes on for 6 times. And so what it does here, it takes one of the values from the PWM pins array and sets pin with the index that you have there, so with the value that you have here, to be an output pin. And then in the loop, you use the same for loop basically, but instead of setting the pin modes, you are actually changing the brightness of the LEDs, of the individual LEDs. So here you choose which LED is going to be, and here you set the brightness, and then you increase the brightness by 1 after each step for each of the LEDs. And then for each of the LEDs, you also check whether the brightness is still less than 255, and if it's not, then you set it back to 0. And then you have a delay of 50 milliseconds. So I will upload it to the board now. So the next challenge is going to be to build our board. So I'm going to rip this off again. So I'm just going to leave the ground connection like this. I'm going to flip it over. And I'm going to go from right to left this time. So yeah, first I'm going to insert the LEDs and the resistors. So I'm going to connect the resistor to the negative leg of the LED, and then span 1 and connect it to the pin next to it. So I'm going to do the same with 5 more pins. I think I'm going to make it a bit more compact, so I'm going to use four pins all together instead of yeah, you can come closer to take a look. Yeah, the resistors, sure. So we need 6 LEDs altogether. So now I am at number 4. Number 5. Number 6. And now we need to connect each of the pins that are the PWM pins to the respective LEDs. So number 3 there. Let's get some more jumper wires. Yeah, great. So I'm gonna use the red ones. So I'm connecting number 5, so which is the next in the list. Here. Yeah. And then number 6. So I'm gonna do a zoom after I finish these. Zoom in. Here to the 3rd LED. Another red one. So from number 9 to the 4th, and then number 10 to the 5th one, and number 11 the other one. I'm going to replace the long cable here, so from pin number 3 with a shorter one. Yeah, so these are the connections you can see on the screen. And now I need to connect the grounds from the left side, so from the resistors to the ground line that is connected to the single ground pin to the one ground pin on the Arduino. So there are more ground pins on the other side, but yeah, we're just gonna use this one ground pin over here to give ground to all of these LEDs. So let's do that. Yeah, you see, like the LEDs are starting to blink already. As I go, so probably you should make this wiring up part while the LEDs are not connected to anything. So while the Arduino is not connected to the power, but I'm just going to hope that nothing bad is going to happen. I think I encountered one LED that might be broken actually. So let's try to change that. Yeah, that was broken, so this we can throw out right away. And let's connect the last one. Now, yeah. Oh, yay. You got a Blinky going. And now, with the example of mine, I would like to increase the speed a little bit. So I'm going to switch back to...
Also, the brightness is set to 50, so is that just like 1/5 of the full power?
No, this is where they start out. So I can, I could start, like, let's say I could specify this as 25, then I go to 50, 75. So this is why they are fading one after another.
Okay, right. So that corresponds to the pin above it, basically.
Yeah, exactly. So this is these are just the these are the starting values, and then with each loop, these are going to be increased in an equal manner.
Okay, yeah. Okay, so it's like a running, yeah.
and I'm going to run this 5 times faster. Let's see what happens. Let's switch to the camera view.
How did you do 5 times faster? Ooh, nice.
So in order to make it a little bit more interesting, I will show you a way how, like another way of looping. So let's convert this setup, so this for loop in the setup. So instead of, you can use, so for loop might be very complicated to understand at first, but you can use also a loop that is called the while loop. And basically a while loop is about this part. So if we put like, so while pin index is less than 6, then something happens. So let's put this here. But then the question is at this point, so what is the, where is the pin index defined? So this is where we need this part as well. So the first part of the for loop, so we need this. And basically we just put it in front of the while loop. So first we declare, like define the variable pin index, that it's 0, and then we type the for loops on while the pin index is less than 6, then this runs forever. But now there's a flaw, so if you don't do anything with the pin index, then it's gonna continue forever. So right after setting the pin mode for the pin in question, we also need to use the third part of the for loop and put it just after here. So basically what we what we have here is the same for loop, but split in 3 parts. So first we specify the variable that is going to be used as our iterator, which is the pin index. We start from 0, and while pin index is less than 6, we use the pin mode function in order to set the pin specified by pin index to output, and then just after that we increase pin index by 1. And then the loop will continue, and it will check whether the pin index is still less than 6. And yeah, so here in this code example, now we have 2 types of loops. We have variables, we have arrays, and we have some timing. So I think this is just enough to get started with Arduino and build like some interesting projects already. And then in order to make, if you want to repeat this in a way that it doesn't look like you know, a bunch of spaghetti on the board, then you can roll back to one of our previous Fab Academy Thursdays where we covered KiCad. So you could actually try to replicate this circuit into KiCad schematic and PCB layout, and then come to the Fablab and try to do some PCB milling, and maybe try out our new reflow oven to make a real circuit board. I'll switch back.
There.
What? Like, I don't put all them.
Ah. Ah, okay. Yeah. Okay, yeah, they're not running. Yeah. That's nice.
But it does the. What is the resistor?
The resistor is to protect the LED from receiving or from pulling too much current and eventually burning out. So because the LEDs, they are usually rated for 25 to 30 milliamps, and the pins of Arduino, they can provide 40. And sometimes it might be that the you know, too much current is flowing through the LED, and then it burns out. But then if you put a resistor in the chain, that means that it takes part of the load.
Yeah, those are fun LEDs.
Yeah, and I think that today we are right in time. So these sessions were kind of supposed to be maybe not more than 2 hours. Usually they are extending to 7 o'clock, which is 3 hours and even more. So, and for basic topics, it really shouldn't be more than 2 hours. And today I think that we managed to do that. So, oh no. Thanks for watching Fab Academy Thursdays. And next week there's not going to be a Fab Academy Thursday. Next week is a break. And then we are going to continue the week after. Thank you very much and